Welcome to Brain Vision.
So now we'll work on problem 144 from chapter 17. So in this question, we're told to find the solubility of copper iodide in a hydrogen cyanide solution. And it gives us the Ksps and Kfs for each equation. So first, let's draw our equations for the values that were given. So we have the dissolution of copper iodide into the ions. So we get Cu plus I minus. And we're told the Ksp for this is 1.1 times 10 to the minus 12. Then we're also given the Kf for the reaction of copper with cyanide. This produces the complex ion copper CN2 minus aqueous. And the Kf that we're given is 1 times 10 to the 24. So what we need to do now is we can add our reactions up and cancel. And so we cancel copper and everything else will come down. Copper iodide, solid, plus 2 cyanide anions, aqueous, will produce the complex ion and iodide. And the K for this, obtained by multiplying these two values, is equal to 1.1 times 10 to the 12. So now we need to know the solubility. So we need to draw an ice table using this reaction here. But first, we need to realize that we're told in the initial problem that we have a hydrogen cyanide solution. So to calculate the concentration of cyanide, we need to do an ice table. So let's open a new page and do that here. So we have HCN plus H2O produces H3O plus and cyanide. So we do an ice table here to see how much cyanide concentration will be produced. We have 0.4 concentration of hydrogen cyanide minus X, no initial concentrations here, plus X, 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 and 0.4 minus X. And so we can set this equal to the Ka for hydrogen cyanide, which is equal to 4.9 times 10 to the minus 10, and that's equal to X squared over 0.4 minus X, the products divided by the reactants. And we get X is equal to 1.4 times 10 to the minus 5. So this is our concentration of cyanide. So if we go back to our first page here, we can write that our initial concentration of this cyanide is 1.4 times 10 to the minus 5, or the initial number of moles. This is a solid, which we don't need to worry about. And so we need to do minus 2s, plus s, and plus s. So we get 1.4 times 10 to the minus 5 minus 2s, s, and s. So we can set this equal to K. K is equal to 1.1 times 10 to the 12 And so we have S squared over this 1.4 times 10 to the minus 5 minus 2s. Now we're going to cancel this because we're approximating that s is small. And so we multiply both sides by 1.4 times 10 to the minus 5 and take the square root, and we get s is equal to 3.92 times 10 to the times 10 to the third molar. And this is the solubility